In this video, we're going to talk about accuracy and precision. So accuracy has to do with how close to a true value or accepted value an answer is, and then precision has to do with how closely a group of data agree with each other, or how consistent a measurement is. So we're going to take a look at that first by just conceptualizing it with like bullseyes, and then we're going to take a look at what a set of data would look like that would correspond to that type of bullseye. So the first one, you can see that all the measurements are right on the bullseye. Hit the bullseye every time. That is very accurate because it's close to what you're trying to get to, and it's very consistent. So we call that both accurate and precise. With respect to the data, you can see that all of these measurements are really close together, okay? And their average comes out to be the true value. So it's accurate, you have 0% error, and it's precise because you have very little deviation between the measurements. The second set of data is definitely not accurate. It's not hitting the bullseye, but it's precise because the measurements are very consistent with each other. And what that would look like with respect to a set of data would be like these groups are all really close to each other, but they're not quite the true value. If your average is 5.87 and the true value is 5.25, you didn't really hit the bullseye, but you were very consistent in doing so. Then we'll take a look at set C, and this one's kind of all over the place. It's not accurate, definitely not on the bullseye, and it's not precise at all either. And so it would say it's neither accurate nor precise. And if you look at a set of data that would follow that, this is all over the place. Your average isn't close to the true value, and there's no consistency either. And then lastly, we'll take a look at this one. And this one is kind of a little bit misleading because definitely not precise. The measurements are all over the place, but if you actually took the average of their positions, they would be on the bullseye. So technically you would call it accurate, even though it's not really giving you any usable information. Because these values right here, their average is the true value. You would say it's 0% error, but you have very little precision, and you're definitely using an instrument you shouldn't rely on. So one of the ways we can quantify precision is with average deviation, which we're not going to talk about in this video, or you could use standard deviation, or there's other statistical ways you could quantify it. But what we are going to calculate is percent error, which is a way of measuring accuracy. So when we're doing that, you take the experimental value and you subtract from that the true value, and then you divide that by the true value, and then you multiply it by 100 because that's what a percentage is. Percent is out of 100. So you figure out how much you're off by and then compare that to what you should have got, and that'll give you your percent error. So looking at set A, there was no error. So set B, we had an average of 5.87, which was off from the true value by 0.62. Then we relate that to our true value and multiply it by 100. And when you plug that into your calculator, you would get 11.8% error. Now, since we know we don't want to upset Stevie the sig fig monster, what we would want to do is realize that since we were dividing, once we subtracted our experimental value from our true value, or all the way around, that value only had 2 sig figs. So then when we're dividing 2 sig figs by 3 sig figs, our answer should only have 2, so we need to round that to 12 just to make Stevie happy.